A lot of experience or even some experience with sort of packaging in Python or using Git and GitHub or just basic ways of sharing and distributing code. This really isn't directed at you. But I think a lot of people are doing really interesting things with Python and writing scripts to do various like mathematical or scientific computation or data science type things. But they really don't know how to share that code beyond their own computer. And the reason I think that is because that's where I was very much when I was in grad school, which wasn't that long ago. And a lot of my fellow grad students were like that. And I wish I had had more motivation and direction to share things that I was working on. And so that's why I'm here and what I'd like to talk to y'all about. So just a little bit of my personal history. If you don't count TI Basic, I learned to program reading this book in high school to build Lord of the Rings fan sites with PHP and MySQL. And probably for everyone's benefit, none of that code exists at all today. And back then, there really wasn't, this was pre-GitHub, there weren't really easy ways to even share code with people. But everything I did there lived on my own machine, and no one ever saw that. In college, I did a lot of interesting things. I studied math and computer science, and all the interesting projects, at least the ones that still live on from college, only exist in this folder in my Dropbox on my computer, and no one's ever seen the the C++ that's pasted in Word documents. Which is also probably a good thing. But so I remember doing this really interesting to me report on approximation methods for the traveling salesman problem. That if I were doing it again today, I would really like to be able to share with the world because I think more people would be interested in it than just my professor. So this was the first thing I ever put on GitHub when I was in grad school at NC State. It's a Mathematica notebook on simulated annealing. Tragically, GitHub doesn't render Mathematica notebooks. But as you look at this, you also notice there's other than this description in the GitHub description thing, class project to visualize simulated annealing, there's nothing here about how to run this, what dependencies it might have, what it might be good for, how others might use it, how others might even start to just look at it. Because if you click on these, it's Mathematica notebooks are less readable than Jupyter notebook files, so it's essentially useless to anyone. And really the whole premise of my talk here is that this doesn't really have to be the case, and it doesn't need to be the case for you. And the other side of that is this was actually a pretty interesting thing. So I implemented simulated annealing from scratch, which isn't that hard, but it's neat to walk through, and Mathematica has really powerful ways of doing visualizations. And if I had taken the time to figure out how to turn this into HTML and render GIFs, which is really easy to do with Mathematica, this could have been a really cool thing on my website for people to see. Instead, it's this GitHub project that has 1 star, which you see as my star. No one's forked it, no one's watching it. Probably no one has ever actually opened these notebooks. So today, I'm still figuring all this out, but maybe arguably one of my more successful projects is this little tool for helping you deploy a Python bot to AWS Lambda, which allows you to a Twitter bot using Python to AWS Lambda, which allows you to have a Twitter bot that doesn't need a server to run on. And a small number of people have found it very happy, or have been very happy using it and have found it very useful. And in some part, that's just because I've learned how to do this better, and people are benefiting from the things I've learned of how to share projects. If anyone wants to see these slides, by the way, the link in the bottom left corner, these are on Google Slides. You can pull this right up. I'm going to have a bunch of links here coming up, and so even later you might want to pull that up, bit.ly/PyData 2016. So this is, again, my premise is I suspect if anyone's here at PyData, you also do interesting things. You've done some sort of interesting data analysis. Maybe even you've just done sort of a toy problem, but you've done visualizations that differently from how someone else has done it, or you have your own special domain that you work in, and there's some open data set that you've looked at that people aren't really looking at in a more public way, and you're potentially doing all that on your computer and maybe telling your classmate or coworker about it, but no one's really getting to see it. So if you take away one thing from this talk, my desire would be for you to have some more confidence to take the kinds of things that you probably do in your free time, because they're the things I do in my free time, and share those with the broader audience. And the rest of this talk is just trying to give you a little bit of what I've learned of things that are valuable to make that happen. I'm not going to go into a lot of the technical details. Largely, the takeaways here are going to be things that you can go and learn further in your free time, and I've tried to provide some links to help you with that. The first thing is, the reality is you just need to learn how to use Git, and Git is a difficult thing to use, but you really need to know how to use it, and I procrastinated for a long time for doing that, but it's how software is exchanged these days. So even in your personal projects, you should try to think about learning to use Git in a way that in the future, if you're not using it with other people right now, start to learn about how you could use it in a way that you could eventually work well with other people. Because it's really easy to use it in a very sloppy way on your own. That isn't going to work well when you need to use it with the team. Code School has some tutorials. The first one is free that you can walk through on how to use Git. It's an interactive tutorial on their website. I think these other ones you have to pay for, but just that is a really good start. This GIF is relevant to anyone who's ever used Git, no doubt. And a great TV show. But something that confused me way longer than I would really like to admit is understanding the difference between Git and GitHub. And so understanding that is going to be also really important for you. And that could be a whole talk on itself. But GitHub also has a nice page on how to use GitHub. But basically, GitHub is built on top of Git, and it's a remote repository for managing your source code. But Git could communicate with all kinds of different remote repositories like Bitbucket or lots of other things. Even Heroku, if you deploy a website to Heroku, basically functions in that way. But GitHub is what people use, and you really just need to know about it. To go back to the title of this talk, making your GitHub the best resume it can be, that was a little bit designed to draw you in here. There's a lot of controversy over that idea of your GitHub as a resume. If you look at my GitHub, it's like 90% unfinished projects, which maybe actually reflects my work life better than I would, more than I'd want to admit. But I don't know that GitHub should really be considered your resume, as people have said. But the reality is, if you're interviewing for a job, people are going to go and look at it. And so if you can make it be attractive and inviting and make it look like you're doing a lot of interesting things versus, one time you forked scikit-learn 5 years ago, I think that's worth doing. So it's ultimately to your own benefit. Pull request, just as an example, that's a weird term. If you don't know what that means, just go out and start learning some of the terminology around GitHub, and everyone here is smart enough to really understand how it works, but you just have to force yourself to sit down and get over the hump, I think. That was what was true for me. So our next piece of advice that I have for you, as you're thinking about a project, you're analyzing some interesting data over the weekend, and you just did it for your own curiosity, you pulled a data set. Think about writing a README to go with that. And there's actually this interesting idea that people have called README-driven development. And the idea there is, so people talk about test-driven development and all these different things. But the idea there is go write down clearly in paragraphs what you're trying to do and what this thing that you're working on is trying to accomplish. And you'll find it's also very helpful just for moving you forward in your own project. And it's also going to be valuable for other people who are looking at your project later on. So think about, you're working on some interesting code. You're working on the simulated annealing project. Write 3 paragraphs about what it does. put a heading that says, installation or dependencies, and write how you get it to run, and then say, oh, here's how you can see the example code. And in 15 minutes, you have something that makes your project go from basically being useless to other people to at least allowing other people to know if it's something that might be valuable to them. Maybe show some example output from your code if that's an appropriate thing. If something's a toy project, it's okay to express that. Say, hey, I just worked on this just to teach myself this. You don't want to use this in production, but just declare kind of what you're doing, and put it in a file called readme.md, and when people load your GitHub profile, that's going to show up right on the front of the project. This is a link to, I think, the original article, this idea of README-driven development. It's worth reading. There are some other people who have written along the same lines. If you're putting software online, the reality is you should seriously consider licensing it. And I am definitely not a lawyer, but as best as I understand it, if you put software online and it has no license in the United States, it's considered copyrighted and no one can actually use your code. And it's potentially illegal for someone to even copy and paste a little snippet of your code. You probably don't want that to be the case. And so you can license it by attaching a license file to it. I think this is an official GitHub site, choosealicense.com. If I'm not 100% sure of that. This is, my animation is defeating me, but this is a license I have on one of my project notes on Dirichlet processes. This is an MIT license, and to add a license to GitHub, all you're doing is copying and pasting text basically into a file called license.md. That's considered the acceptable way to license some software. Let's see if I can get to that link. Well, choosealicense.com is going to walk you through how you can choose a license to put with your project. You can read through it for yourself, but it's a really helpful way to get started. It tells you some projects that have various licenses. If nothing else, you can put a public domain license. I guess on here they have an unlicensed, but you can declare in your code, put some text in and say, you can use this for whatever you want. You can make money off this. You don't even have to attribute it to me. You could consider doing something like that. I've done that with some projects. It's a small thing, but it's potentially a very important thing, and it potentially allows people to use the things that you're working on and the things that they're working on, and you could require them to attribute them back to you, and it makes you look good, and maybe makes everyone win. Another valuable thing you can do is include some runnable examples. Including IPython or Jupyter Notebooks is something people have been doing a lot recently. There may be some limitations to that, but I think it can be a really nice thing. A limitation is, for example, they don't diff very well in your Git thing, so it's hard to do version history on a notebook. Another thing is, if you have a notebook, and I guess this is true with any examples, but your notebook could get out of date with the rest of your projects. You have to force yourself to update your examples as you're updating your code. But all that to say, I think it's a really nice way to do this. The project I really like is PyLDA Viz. So this is a way for visualizing latent Dirichlet allocation topic models. So ways of looking at categories of text. It's based on an R package, but it's a guy named Ben Mabey out of Utah writes this, and you can just go pip install it, and then you can get really beautiful visualizations of your topics and topic models. But so to start with, you load this GitHub page, and he has this really nice README. So everything you're seeing here is just text in his README file. You can see the raw file, right? So this is just a text file that he has as a README. as a restructured text file. And GitHub is going to render that on the front page of his project. So if this was me a few years ago, I would have done this thing and had all this nice code, and then you would have loaded this, and you would have just seen this big index of all the code that's available here, and I would have written nothing about how you use it or how you run it, and it would have been useless to everyone. But if you put a README file, then GitHub renders it. You can look quickly and see what this thing is supposed to do. Even has a badge showing that it's on PyPI, so you can pip install it. A badge showing his build is failing on Travis or something, and that his docs are updated on read the docs. You can learn how to do these things so they update automatically. His README has really nice instructions on how to install, and he doesn't have really thorough documentation on how this thing works. I guess so he does have basic documentation on read the docs. Maybe it's actually better than I remember. So it's mostly just a change log that he has on read the docs. But he's included this really nice Jupyter notebook, which he links to, and it's just a file committed in the GitHub repository. And with text and code, he walks through how you use this project that he has. So you can, on NB Viewer, you can go and just look at this thing, and on NB Viewer, unlike GitHub, renders the JavaScript, so you can even see how it visualizes the topics right on here. And then also you could download the notebook, and then you could interact with it yourself. The code is available, so you can rerun the notebook, you can modify it, and learn from his examples. So it's a very interactive way to understand the code. So, you're doing some interesting data visualization or training a machine learning model or something in your own free time, or looking at data in a new way. You put together this notebook, and then you can put that online, and other people can go and download that and look into it. There's another project called Binder, which actually Binder allows you to add a badge right onto GitHub, and when you click it, it spins up a virtual machine that allows you to interact with the notebook without even cloning it to your computer. So this is mybinder.org. They have some example projects. So on the README, there's a button that says Launch Binder. I don't know if we can get this to start in time or not, but it's actually going to create a virtual machine, install the dependencies, the Python dependencies using the requirements file, and then launch the notebook right here for you to see. So you can imagine, again, back to my terrible example from grad school, I did this really cool thing to turn into my professor, and I probably got a fine grade on it. But that's fine. That's basically as far as it went. But if I had done it in a language that wasn't proprietary, and I had known more and been motivated more of how to share this, I could have taken this thing and had a link to it straight from my About Me page on my blog, or put it on my Twitter or LinkedIn or something, and a few years down the road, I'm applying for a job, and people go, start clicking on it like, oh, this guy's really smart. He knows how to implement simulated annealing himself. Instead of, oh, here's this huge file that is meaningless to me. Right, so we can now look straight in this binder file. So you could do this with your own project as long as it can install the dependencies from pip. It's really cool, very powerful thing, very powerful way to work. All right, so this is a really important thing, and also should be a talk or a seminar or a class on itself. But I think in working on your side projects, you really need to think about always being engineering that software. And what I mean by that is it's very tempting for us to write something thinking we're the only one who's ever going to see it. And so I can use X or XX, and then like XXX is all my variable names, or X and Y and Z, and write these horrific nested list comprehensions in Python that no one's ever going to be able to dissect. But I think it's really worth thinking. I mean, it's almost a self-fulfilling prophecy, right? No one's going to see this software. You're probably going to end up writing it in a way that you're not ever going to be able to share it with anyone because it's going to be incomprehensible. At the same time, in your work, if you're out of school and you do something like that in your work, it's like a joke to say no one's ever going to see it. At some point, you're going to have to hand that off to someone else. So my recommendation is even when you're doing something on the side or something quick, like try to be thinking about how to write that using good engineering principles. A huge thing that we all do is have these magic constants. So the worst example of this is we have hard-coded file paths all throughout something. So we need this data, and so we just have these hard-coded file paths. So that is impossible for it to run on any other machine that doesn't have the exact same username and file structure as your computer, right? So if nothing else, think about, hey, I'm not going to hard-code these file paths. I'm going to put the file paths as a defined constant at the top of my code. So if nothing else, people can just come in and change that constant and then run it. Or just another example of a magic constant, just like using numbers that make sense to you, but someone else reading it might not understand it. So give your numbers a name by assigning them to a variable and then use them or something like that. Use descriptive variable names. We've all written things with really bad single character variable names and other bad things. Think about writing reusable code. Put things into functions so that you can call the function instead of copying and pasting. Just kind of basic things. Force yourself to think about that, and as you write things, maybe it doesn't make sense for you to write that the first time, but force yourself to say, okay, I got this to work. Now I'm going to go back and try and put this in a way that makes more logical sense or that's more maintainable. Think about writing more functions and use good names for your functions instead of just writing this 1,000-line script that doesn't call any of your own functions. Split things up into meaningful chunks. A paper was just put on online called Good Enough Practices in Scientific Computing. This would probably be a valuable paper for a lot of people, but they have a big outline of the points of their paper. And number 2 is tips for software engineering, essentially. Some of these things we're already talking about. Give functions and variables meaningful names. Make dependencies explicit. This is probably, if you can consider what you do scientific computing at all, this is probably worth going through. I guess once you turn on animations, you can't then click links, so maybe I just don't know the... Yeah, so here's that whole paper. And that's just the second paragraph, and it's a whole long paper. They flesh out each point in that outline, and then the outline has things on data management, software, collaboration, project organization, keeping track of changes, manuscripts, a lot of the things we've been talking about here. Go and read through that and teach yourself that, and over time try and implement more of those things in your own practice. It's going to pay off. All of us are probably going to end up writing code for jobs in the future, even if you're in school and maybe you're not planning to be a software engineer, but you're planning to be a scientist or something else. You're probably going to end up writing code. I guess today is the day to stop the generational bad habit of writing terrible and unmaintainable code that we've all learned in grad school. Declare your dependencies. This is actually something that's been particularly frustrating to me at PyData. I was at PyData in New York City last year, and people are doing tutorials, and they're putting their IPython notebooks online, and they're not even telling us what version of Python they're using, right? So we have 2 different versions of the language that the syntax isn't even completely compatible. And they're saying, here, go run this thing, and they're not even telling me what interpreter it needs to run. I mean, that to me seems like a very basic thing, and people aren't thinking of that. So you need to declare your dependencies, starting with your Python interpreter, and then otherwise learn to use virtual environments, or I would argue for Conda environments. Learn to write requirements files or Conda environment files. I have found over the last year Conda environment files a really nice, or Conda environments and the environment.yaml files, a really nice replacement in many cases to virtual environments. Among other reasons, it allows you to specify what version of Python you're using. So here's an example conda environment file. You're naming your environment, you're specifying your dependencies. It's not just Python packages, it's any binary that's on the Anaconda repository. You can specify the version as Python 3, and you can also specify requirements from PyPI using this pip sub thing. And then you can run that as I have here, conda env create, and then you can specify the environment file, and it's going to create this virtual environment that's going to have all your dependencies, and it's going to be separated from any other dependencies you have on your system-wide Python. It's a really, really nice thing. So my work, I work at a company called Distill Networks. We're a computer security company, and on our research team, we do a lot of small research projects. And we have this huge GitHub repository that has a folder for every project. It roughly corresponds to Jira tickets. And so when we start a new project, we create this folder with the Jira ticket number, and then I have a script on my system that automatically creates a conda environment file named after the folder, and then adds the dependencies I use in most things. And that way, when we are running each other's code, we don't have to actually know what version of Python someone used on this research project. You just go into the directory and say conda env create, and conda is going to install whatever version of Python it needs and install the dependencies, and then you can type IPython, and all of a sudden you're being able to run the code, not caring whether or not there are parentheses around the print statements. I've found this to be one of the most beneficial tools I've had in the last year, and my team has found it really helpful. If you haven't looked at it, I would encourage you to do that. That's through Continuum. You can search Continuum Anaconda or Conda and find out how to do that. People are critical at times of this idea of idiomatic code or Pythonic code. My opinion is it's worth learning how to write code in a way that the Python community at large has deemed valuable and readable and good for the community. If nothing else, if you decide you want to break the rules, at least know what the rules are first, is kind of how I look at it. A really valuable thing you can be doing is read good books. Python Cookbook, really nice book, and Fluent Python is a book specifically about like what are the nuances of Python that really set it apart as a language. If you've come to Python from another object-oriented language, you probably write what a lot of people would consider to be very bad Python. I came to Python having done a lot of C++ in college, having done some Java, and I tried to write all my Python in the same way. I tried to create a class for everything, and ended up just writing this terrible, bloated, unreadable Python code. And over the years, I've learned to write Python in a way that makes me happier, it makes the people I work with happier, it makes my code easier to read and maintain. And I think it's worth learning some of those ideas and concepts. Another great thing you can do is get feedback. One of the most beneficial things for me was taking my second job out of grad school. I worked with a lot of Python programmers for the first time. Before that, I had been kind of doing Python on my own, and people were very critical of the things I was working on, and I learned so much, and I was able to develop a lot, and now I get to be the critical one of my coworkers, so it's great. If you're in the area, we have the Python meetup. Chris, did I see Chris in here? Chris, who's one of the hosts of this event, runs that, and it's a great group. And you can go and work on things and let other people see it and let other people give you feedback and be willing to be told you're wrong or that you could do things in a better way. My old boss, Andrew Montalenti, Parsley, who's sometimes a PyData speaker, has a document called the Elements of Python Style. This is kind of how Parsley has learned to write Python, and this is a really good document. And again, you know, it's not the law. You don't have to follow at every point, but I am strongly of the opinion that it's worth hearing what other people have to say. It's on GitHub, Elements of Python Style. You can Google it and find it, read through it, and think about that. Um, Another thing to consider is learn how to write command line tools. This seems like a daunting thing, but there are a number of Python libraries that makes writing command line tools pretty easy. It's a way that you could allow other people to interact with your code without having to actually modify or edit your code. So for example, you need to specify a file path to write this code. Write a little command line tool that just takes the file path as a command line operator and then does the analysis. I really love Click. There's a little bit of a learning curve to get used to it, but it ends up allowing you to write really nice code to make a command line tool. So it's using Python decorators to specify the arguments, and you can do things like this. There are a number of other alternatives, and you can look into, but this is one I've really enjoyed. Using tools like Fabric, which does more than this, but you can encapsulate different commands in Fabric, or using a makefile. Here's an example of something I've done in a little project I have. So this is a makefile, and it allows you to create these commands, which is the word before the colon, and then it'll just run a bunch of things all together. If your project has to run a bunch of different scripts or a bunch of different commands, try and encapsulate all those commands. Don't make people just go and copy and paste a bunch of stuff, because that gets really annoying. This is a nice short article writing a command line tool in Python in under 60 seconds. I recommend going through and looking at that. All right, so also something that I put off way too long is learning to use setup tools to make something installable in Python. So for a long time, if I wanted to import something, I would just copy and paste or make a symlink or something with the folder of the code that I needed to import. And it took me way too long to be able to learn how to use setup tools so that you can do Python setup.py install and then install the module into your environment so that you can import it. It's not as hard as you might think, and it's worth just sitting down some weekend and just figure out how to do it. So instead of trying to write instructions on your GitHub project for people like, oh, here, go copy and paste this code into this directory and then you can import it, you can tell people they can just do git clone your project and then cd into the project and then do python setup.py install, and it'll make it importable. There's a really nice tutorial. Again, this is just for you to go look at later, but it's called an example PyPI project. This will include using setup tools and then also deploying that to PyPI, the Python package repository. So then not only can you do python setup.py install, but someone could just do pip install and then it'll go grab it from PyPI, which is only one more step really beyond using setup tools. Largely as a concluding thing, I would commend to you, there's something called the cookie cutter project. This is actually the template for Python, but cookie cutter is a project that allows you to create a whole folder structure and like the default files and things you need for a development project in all kinds of different languages. So there are sample cookie cutters or cookie cutter types down here. A Flask project, a pip project, a Python package, and a lot of it's Python, but there are things in other languages, a Sublime Text plugin, a Django project, C++ project, all these different things. And it provides you pip install it, it's a Python thing, and it gives you a command line tool called cookie cutter, and you say cookie cutter and then reference the GitHub repository you want to create to use as a template. So I'm going to try and walk through an example of this. So there's this cookie cutter Python package repository. So we can run cookie cutter and then specify the repository, and see if the internet lets this work. But it's going to clone the repository, And then it's going to create a Python project using that as a base for the project. So it wants to know my name, my email address, my GitHub username. I'm just going to leave the default project name, description. My PyPI username is also tdhopper. The version number that you want to start your project with. Do you want to use PyTest or not? I really like PyTest for doing unit testing. Do you want to deploy to PyPI using Travis? That's a little bit more of an advanced thing, but that's how you can automate. If your software passed a test, you can automatically update it to PyPI. We're going to say no for now. And then do I want to create a command line interface using Click, which I just talked about? I really like Click, so let's go ahead and do that. Create an author file. I'm just going to have one author, so I'm not going to do that. And then it's even going to let me choose a license, an MIT license I often go with. So we're going to go ahead and do that. So this created a directory for me called Python boilerplate, which was the default name. And if you open that, which didn't exist before, I don't know how to make the text bigger, but it created this folder called Python boilerplate, and all of these files are things that it created, and it's a little bit overwhelming that you need all of these files for a Python package, but it starts to make sense once you learn it. So the core code is in here in the Python boilerplate folder. Here's our basic command line interface. Here's the Python boilerplate, which is where you're going to start writing your code. And created a basic test folder that you can use to start writing some tests. There's a README that you can go in and update to have the things you want. A history file for you to keep a version history. A list of or instructions on how people can contribute. And then importantly, it's going to give you a basic setup.py file. So you could already go on this project, and we could say pip, and and so now we could launch Python and say import Python boilerplate, right? So we've already imported the module that we just created. So if you've been working on a script that does something, you could take this and start to integrate your script right in here. It's going to have the make file is going to have some commands that you can use to build the documentation. So you could upload this to read the docs. It'll run your tests for you using talks. You can type make release, and it's going to release it to PyPI for you. It's just going to automate a lot of this stuff. So all of these things are, opens lots of doors of things to learn, but this is a really nice place to start. Go and start to learn what these various things do, see what happens when you modify various things. I've found this to be an extremely valuable project. I'm about out of time. This is just a recap slide of my recommendations, but I would like to go ahead and take any questions that we're able to take. Jenny has the mic there. So.
And we're only going to do a couple of questions because our birds of a feather are going to start. So while you're thinking of the questions, I want to let you know that they unarmed the security doors until 5 o'clock. So you can leave through those doors until 5 o'clock. And the birds of a feather are going to be out under the tents. And if you go to the Bluemix group, you can find out where they are. So how about some questions for Tim?
I'm happy to field questions tomorrow or dinner tonight, and you can email me.
Or your lightning talk about IBIS?
Yeah.
There is one more slot for our lightning talks. If folks get out there quickly, you can sign up. So how about we dismiss them, Tim?
Sure.
And then you guys can talk to him up here. So round of applause.
Thank you, everyone.